Process begins when wastewater, which is anything that runs down your pipes, arrives at the treatment plant and enters this building. The wastewater passes through step screens specially designed to remove large solids which should never be in the sewage system. Anything that caught in the step screens is removed, washed, and taken away to the landfill. Whatever passes through that step screens comes here to grit chamber. This grit chamber is designed to allow heavier solids such as dirt, sand, and rocks to sink to the bottom. This allows only the wastewater to flow through the next stage of the treatment process. The velocity of the water is slowed and air is pumped through the pipes into the water to facilitate this separation. The solids are pumped off the bottom of the grit chamber and also taken away to the landfill. The waste removed from the step screens and grit chamber combined is about 1 ton per week. We again strongly urge you to only flush appropriate disposal material. The wastewater is now finished in the grit chamber and is split into opposite directions, leading to one of our 3 primary clarifiers. Primary clarifiers use the law of gravity to allow the dense material called sludge to settle to the bottom of the large basin. The water comes up through the middle and slowly makes its way towards the outside wall, spending an average of 5 to 6 hours in a basin. All the while allowing the solid to settle to the bottom, there are sweeping arms on the top and bottom of the primary clarifiers used to either get rid of the floating debris or to collect the sinking sludge, all of which gets pumped to the digester. Much of the foam and other icky debris you see on the top of the water is supposed to be previously removed in the grit chamber. This is yet another reason a new treatment plant is being built, to replace old or damaged equipment and outdated process. 90 to 95% of the settleable solids are removed by the time the wastewater leaves the primary clarifiers, and 40 to 60% of the suspended solids are removed as well. The water now flows from the 3 primary clarifiers to this building, which is known as intermediate pump station. The water flows in and is brought to a higher tank, all accomplished with a screw pump. Each screw pump is capable of pumping as much as 10 million gallons of water every day. From there, most of the wastewater flows to the aeration basin, while some flows to the trickling filter. On top of the trickling filter, you can see the wastewater is sprinkled over this plastic media. The purpose of the vast and multiple layer of media is to expose the wastewater to a large surface area of a good bacteria growing on the plastic. This removes any bad bacteria as well as harmful chemicals such as ammonia. Although the trickling filter used to be cost-effective and natural form of water treatment, it now no longer provides the quality of cleanliness needed to comply with the current standards, which includes nutrient removal. A process the new treatment plant will better accomplish the water that does not find the way to the trickling filter flows to one of these 4 aeration basins. In each basin, we find good bacteria or microorganisms to help treat the wastewater. A large wheel provides mixing and air, while the waste from the sewage provides the food. Since air is provided, this is an aerobic treatment process. It's a natural process, harnessed and expanded to fit the city's growing demand, and provides all that requires to keep those cute microorganisms happy in good growing environment. After flowing through either the trickling filter or the aeration basin, though wastewater comes here, one of the 2 secondary clarifiers, much like the primary clarifiers we saw earlier. These clarifiers allows the dense material to sink to the bottom. A large portion of activated sludge that collects on the bottom of these clarifiers is returned to the aeration basin in order to reuse the microorganisms, while any excess is pumped off to the digester. for further treatment after spending approximately 18 to 24 hours in the treatment plant. The wastewater now flows through the chlorine contact basin. This chlorine pump takes the chlorine from its holding tank and mixes it into water. The chlorine contact basin slows the water flow through these long channels and gives the chlorine time to perform proper disinfection before discharging the clean water into dry creeks. Wait a minute, we forgot about the solids and sludge from earlier. Let's go over the digesters. Unlike a aeration basin that use an aerobic treatment process, that digester operates on anaerobic treatment or treatment without air. Though technology and innovation, we again here adapt the natural biological process similar to what happens inside a human digestive system and produce it on a very large scale. It takes a minimum of 15 days for the sludge and solids to pass through all 4 digesters and move on to the next step of their treatment process. As the sludge comes out of the digester, it still has a high liquid content. So, in order to remove some of that liquid, it comes here to the belt press. As the sludge is pressed through these folding layers of the belt press, it goes from 4% solids to almost 18%. Now, that may not seem like much, but remember, your body is only 40% solid matter. The sludge makes its way out of the belt press and it collected here. This treatment process is so thorough that even flies, cockroaches, rats, or other rodents are not attracted to this newly dried material, which will be either used as fertilizer on farms or taken off to the landfill. Thank you.